Okay, today we're going to work on some trig proofs.
Oh,
And I'm going to first show you, once I show you where these identities come from, you don't have to prove them, you just have to use them. Okay? So, what is this? This is a circle, right?
yeah.
If you were to, let's say, make a triangle inside this circle, see this point right here? It's called XY. Do you agree that from here to here, this leg is called X units, and this leg from here to here is called Y units? From here to here is the hypotenuse, or the radius. Does everyone agree with this triangle right here?
Yes, ma'am.
Okay, now, what kind of a triangle is this? It's a right triangle. And does everybody agree with the Pythagorean identity or Pythagorean theorem that says that if you were to square these two legs, you would get the hypotenuse squared? So does everyone agree to this statement right here?
Yes.
Yes or no?
Yes.
Okay, everyone agree to that. Now, this is what's happened. They've taken this identity, which is just the Pythagorean identity, or the Pythagorean theorem, which says x squared plus y squared equals r squared. If you took this and divided everything by r squared, I want you to do that. Divide everything by r squared. What you have here, what's r squared over r squared? 1. Now, do you remember what, I don't have it on your paper. What is cosine equal to? Cosine is x over r. So what do you think cosine squared is? Is what? So you're going to call this x squared over r squared is cosine squared, and what do you think y squared over r squared is? And that's your first identity. So, can you memorize that? Cosine squared plus sine squared is 1. Now, what you can do with this identity is now, you're going to do two more things with it. I rewrote it here twice for you. Cosine squared plus sine squared equals 1. Cosine squared plus sine squared equals 1. What you can do now is take them and divide them. If I divided this whole thing by cosine squared, this is what you get. Cosine squared x, and cosine squared x. Well, what's cosine squared over cosine squared? Actually, I should have written it here. Cosine squared x. Cosine squared x over cosine squared is 1. What's sine over cosine? What's tangent equal to? Whoops. Tangent, you could say it's sine over cosine. So sine over cosine would be tangent squared. And then this is going to be secant squared. 1 over cosine squared is secant squared. Now you could also take this identity and divide everything by sine squared. And you end up with, what's cosine squared over sine squared? Anyone know what cosine over sine is? Yep. So you have cotangent squared x plus 1 equals cosecant squared x. So we have 3 identities that you need to know. The first, the major one is cosine squared plus sine squared equals 1. Then you have 1 plus tangent squared equals secant squared, and cotangent squared plus 1 equals cosecant squared. Now, what you can do with those 3 identities is you can rewrite them. So in other words, you could take these three identities and you could write cosine squared is equal to 1 minus sine squared. You could say sine squared is equal to 1 minus cosine squared. So there's some more. You can take 1 plus tangent squared and you can write it as 1 equals secant squared x minus tangent squared. And you could say tangent squared x is equal to secant squared minus 1. Do you see what I'm doing? I'm just moving things around.
Can you go back?
This one? Good. And the last one. Cotangent squared x plus 1 is cosecant squared. How can you solve this for cotangent? What would you do? Bring this over. And you could say 1 is equal to cosecant minus cotangent squared. So now, flip to the back. This is what we're going to do. We are going to prove a bunch of identities. You're going to work on one side and use factoring, substitution, multiplying, dividing, adding, subtracting, getting common denominators. You are going to prove that one side equals the other in a minute. So a couple things I just want to refresh your memory. That tangent, another way of saying tangent, instead of saying y over x, you could say sine over cosine. Cotangent, instead of saying x over y, you could say cosine over sine. You should know these reciprocal identities. Sine is 1 over cosecant, cosine is 1 over secant, and tangent's 1 over cotangent. These are the 3 Pythagorean identities we just proved. You're gonna rewrite them several different ways. Now to prove identities, this is what you're gonna do. You're gonna transform one side of the equation into the other. Only work on one side, not both. You work vertically. You're gonna use substitution. You're gonna write as much as you can in terms of sine and cosine. So when you see tangent, try to write it in terms of sine and cosine. And use all different kinds of methods to break things down, like factoring. You have to know how to do factoring. And you want to know the identities. The more you know them, the better, the easier this section will be. And always work vertically. Do not work horizontally. So they start off really easy. We're going to do these 7 together. Number 1. Your job is to prove that the product of cotangent times sine is equal to cosine. You're going to work with one side. Either work on this side or work on this side and work vertically. Now I look at this side and I think, well, cosine, there's not much there. Cosine is about as bottom line as you can get. So I know that I can use some substitution here. I know cotangent is 1 over tangent, but that's not going to do anything for me. I could call that 1 over tangent. But that substitution doesn't do anything for me. What's another way I can rewrite cotangent? What's another way of writing cotangent? I gave it to you on this sheet right here. Write it in terms of sine and cosine. So cotangent is cosine over sine. So instead of this, you're going to write cotangent and now, what did you learn? How to multiply fractions. What do you do with these two right here?
Cancel out.
They cancel out, and what do you have?
Yeah.
You have cosine of x is equal to cosine of x. And you're done. That's how easy that one was. Number 2. We need to prove that the cotangent of x divided by the cosecant of x simplifies to cosine of x. So what I want to do is substitute cotangent x. What's another name for cotangent of x?
Cosine over sine.
Cosine over sine. What's another way of writing cosecant?
1 over sine.
1 over sine. What do you do when you have a fraction divided by another fraction? What do you do?
Multiply by the reciprocal.
Multiply by the reciprocal. Let's do that. So you have cosine. You're going to flip this. And what cancels?
Sines.
And you're left with cosine of x over 1, which is cosine of x. Notice how I worked vertically. Next. Check this one out. What does the left side tell you to do?
Foil.
Foil. Good job, foil. Let's foil.
Good job.
What is this called though? The difference of two perfect squares. What did you learn when you FOIL and you have the difference of two perfect squares? What special thing happens?
There's no B.
There's no middle term. Good. What's cosecant x times cosecant x? So we know, we look at this and we recognize that it's the difference of two perfect squares. And I know that, and I don't even have to write it. I know that the next two will do what? Cancel out. So what's the outer one's gonna be? Okay, so I look at this and I go, oh, I recognize that this is one of what? One of the identities that we just proved, right here. And what does that equal? What's cosecant x minus 1 equal to? What's it equal to? Cotangent. So this is equal to cotangent squared x. So once we have proven it, we can use it. Yes or no? Do you see that?
No, I don't.
You don't?
Why is that equal to cotangent?
Because, well, we started off with this, and if you divided everything by that, you end up with this, right? And you can rewrite this formula. We talked about rewriting this, rewriting it as cotangent is cosecant squared minus 1. So based on this, right here, cosecant squared x minus 1 is cotangent. Cosecant squared x minus 1 is cotangent. So cotangent, you just substituting. Do you get it? Okay, what does number 4 look like we could do on the left side? What could we do? What's this one called? What's that? Difference of two perfect squares. So anyone think they know how to factor this side? How would you factor it? How would you FOIL factor? You could go that route, but let's use the difference of two perfect squares. This is going to be secant squared x and then plus tangent squared. I probably should have left forward. Write it. So secant squared x minus tangent squared x, secant squared x plus tangent squared x. Okay, now I want to do some substituting. Which of those three trig identities could I substitute? I'm trying to get this equal to 1 plus 2 tangent squared. So let's go here. Let's look Here. So this is what I have. Can anyone see a substitution? What is secant squared x minus tangent squared x equal to? 1. So this whole thing equals 1. Now, I want to get this, you really don't need that 1 now. What I'm trying to keep is the tangent. So I want to rename secant squared x. What is secant squared x equal to? What's secant squared x equal to?
1 plus tangent squared.
Okay, so I'm going to replace secant squared to 1 plus tangent squared x. So anyone know what 1 plus tangent squared x plus tangent squared x is?
1
What's-
plus 2 tangent
Yeah, 1 plus 2 tangent squared x. Because these two are like terms. 1 and 1 is 2, and that's what you were trying to prove. So it equals 1 plus 2 tangent squared. Next one. You what? You don't understand that one?
Oh, no,
I have a question.
Yes.
When we take this test, are we gonna have like a sheet?
Nope, you have to know them. You have to memorize them. You have to memorize all these identities. And I will show you, as you do the homework, you will start to memorize them. But I'm gonna show you a trick when it comes to that time, what to do. Okay, this one. This one has two separate, and they are getting it to be a product. So what I would do on this one, especially because it's in secant and cosecant, you're gonna rename this as 1 over cosine squared. Now, I don't expect you to know how to do this prior to me showing you right now. But after going over them, if I gave you one like this one, I expect you to be able to do it. Once I go over it, you should be able to imitate what we're doing in class, okay? So what you see here, first of all, here's two little triggers here. I see the word secant and cosecant. So try to name them in terms of cosine and sine. That's one trick. The other trick is if they have a plus or a minus, and then they turn it into a product, your job is to get a common denominator. When they go from 2 terms to 1 term, you want to get a common denominator. If you were to add these together, what would be the common denominator? Anyone think they know what it is? Cosine squared x plus times sine squared. That's your common denominator. Okay, so what you need to do, you need to go back now, and you're gonna multiply this by sine squared x and this by sine squared x. So what's 1 times sine squared x? Sine squared x. Now this one you're gonna multiply by cosine squared x and multiply this by cosine squared x. What's 1 times cosine squared x? Cosine squared x. Now guess what? We have a common denominator. What's our common denominator? This cosine x sine squared x. So cosine squared x sine squared x is common. So what you're going to do is add the numerator. Now you've got sine squared x plus cosine squared x all over now on one of our identities we know what this is equal to. What's another name for this? It's the very first one we did. What's cosine squared plus sine squared equal to? 1. This whole thing equals 1. Now, guess what this is? What's 1 over cosine squared? It's secant. 1 over cosine is secant, and what's 1 over sine? Cosecant. So you now have, and I don't have enough room here, but it's secant squared x times cosecant. This over this is that, and this over that is that. So we're done. Next one, number 6. Number 6, you have 2 fractions. They're asking you to do what to them? Add them. Let's do what they're telling us to do. Because I cannot rewrite any of this in terms of anything. So I'm going to add this fraction to this fraction. Well, you're all smart enough to tell me what the common denominator is. What is the common denominator between, what I would do is put parentheses around all that, like that. What's your common denominator?
Sin x times 1 plus cosine.
Yep, you got it. Okay, so I work backwards now. So this is what I want to get this fraction equal to. I have the sine x. I need to multiply this by 1 plus cosine x. So as long as I multiply the top by 1 plus cosine x, what's 1 plus cosine x times 1 plus cosine x? Anyone think they know? Can anyone FOIL that? It'd be 1 plus 2 cosine x plus cosine squared x. Now on the second fraction, I have the 1 plus cosine x. I need to multiply this by sine x and this sine x. What's sine x times sine x?
Sine squared x.
Sine squared x, very good. Okay, guess what? Now I have a common denominator. What's my common single denominator? It is sine x times 1 plus cosine x. So this is my common denominator. Guess what I'm going to do with all of this? Combine it. I have 1 plus 2 cosine x plus cosine squared x plus sine squared x. Does everybody see that? This, and plus that. Now, we need to do some substituting. Does anyone know what we can substitute? The very first identity that I showed you. What's cosine squared x plus sine squared x equal to? What's that equal to? This is equal to 1. So if we replace this for a 1, what's 1 plus 1? So does everyone agree that this is 1, and 1 plus 1 is 2? This is what you have. Okay, now think of factoring. Is there something common in the numerator we can yank out? A 2. Is there anything we can cancel? Anyone see something to cancel?
1 plus cosine x.
Yep, those cancel. So what you have is 2 over 1 times 1 over sine. Well, what is another name for 1 over sine?
Cosecant.
We have just proven that this side equals 2 cosecant x. One more. Are you loving these?
No.
Okay, so someone, I think I've gotten this question a lot today. What chapter's harder? Chapter 9 or chapter 8?
Whatever this one is.
To answer your question.
The last chapter is done.
Last one. How do you get this in terms of that? Well, I think what I would start with, I like the left side. Let's rewrite this. You've got 1 in the numerator. What's another name for cosecant? 1 over sine. Okay, so. What do you think you're gonna wanna do with these two? Get a common denominator. If I multiply this by sine and this by sine, everybody see that? You've got 1 over 1 minus sine squared over sine. What's another name for 1 minus sine squared? 1 minus sine squared is what? Cosine squared. So this is what you have, 1 over. You have cosine squared x, I'm substituting. So this is a fraction over a fraction. What do you think you do now? Flip and multiply. Whoops, cosine squared x. Now, you don't need this 1 over 1, right? So that's what you have. How do we get this to look like secant x tangent x? Well, if you think of this as you've got sine of x over cosine x, cosine x. What's sine over cosine? What does this equal right here? This is equal to tangent. And what's 1 over cosine? And guess what you have here?
Oh my gosh.
The
Oh
answer.
my gosh, that's what you have. Just backwards. Just fix it. Okay, these are your homework for tonight.